So let's solve our derivation of latus rectum of a parabola. So in our previous example, I have derived the LR of a ellipse. Now let's derive the LR or latus rectum of a parabola. Now, if you would consider a parabola that is hopping to the right, okay, so at vertex 0, 0, okay, so LR is the chord that is passing through the focus of the parabola. Okay, of course we have our focus F, and this can be, or it has a coordinate positive A0, and of course we have our directrix. Note that it has a length A, and it is equal to the length of our directrix because they must be equidistant with the focus. So this will be our directrix, okay, in which the directrix has a coordinate equal to, or a point in which it, or the point within the directrix is also within the axis of our parabola, in which we have negative A0. Okay, so from here we'll have x is equal to negative A, so x plus A is equal to 0 will be the equation of the directrix. Now let's locate for the LR. Our latus rectum is the distance the latus rectum is this distance, which is equal to our LR. Now, if I would consider the first half of my parabola, and then I will use my reflection property later on. So let's have this point from my focus. I have A, right, and a value Y. Okay, let's call this a value Y, wherein this will be the height of our, or the length of our half of our LR, or our LR over 2. So let's call this as AY. Okay, this will be their coordinates. Seems true. So if I would take its perpendicular distance to this directrix, so let's call this as my, first this will be my negative AY. Okay, now take note that this will be my P, okay, point at any point, the point at any point in the parabola, and this is my directrix. So therefore I may call this as my PD, okay, and this will be equal to my PF, okay, and that would be my point Y, okay, or my length Y. So from here I will have PF is equal to my PD, but my PF is equal to my Y, right? So therefore I will call this as my Y is equal to my PD. What is my PD? What is my PD? So of course my PD is equal to square root of x value. We have A minus x sub 2 minus x sub 1 negative of negative minus negative A square, plus we have Y minus Y, so this is just equal to 0. So since my PD is equal to this, so Y is equal to square root of my PD, right? I will just substitute that one. So I will have A minus negative A will be equal to 2A squared. Okay, so from here my Y will be equal to square root of 2A squared is equal to 2A. Now my Y is equal to the half of my LR, right? So therefore I may conclude that my LR is equal to 2y. So therefore my LR is equal to 2 multiplied by the value of y, which is equal to 2a. So therefore my LR is equal to 4a. So the length of my latus rectum is equal to 2 multiplied by 2a, which is equal to 4a. Or wherein my a is the distance from my focus to the vertex, and also this is the distance from the directrix to the vertex, right? So therefore we may say that the distance from our directrix to our focus is equal to our LR all over 2, or the latus rectum divided by 2. Okay, because basically if you would add this, a plus a is just equal to 2a. So that is for our latus rectum.